Now, before we convert a repeating decimal into fraction, let's find out first what is meant by a repeating decimal. Repeating decimal, or the other term is non-terminating decimal, which means that the decimals do not terminate or do not stop. Examples: 3.1212121212 ... 4.345345 ... 5.67, and we have here a line above the 0.67. Now the three dots is what we call the ellipsis, while the line here, this line above the dot 67 or 0.67 is what we call the vinculum. If you see these symbols, that simply means that the numbers are repeating or non-terminating, okay? Now, I have here an example of a fraction that when converted into decimal, it will have repeating decimals. So 10 over 3. If we convert 10 over 3 to its decimal form, we can use the long division. So we have here 10 divided by 3 equals 3. 3 times 3, 9. So 10 minus 9 equals 1. And we will put a point here or dot and this side too, and we will bring down, we will add a 0 and bring it down. So 10, so the 1 here becomes 10 again. So 10 divided by 3 equals 3. 3 times 3, 9. So 10 minus 9 equals 1, and we will bring down a 0 again. So 10 divided by 3 equals 3. 3 times 3 equals 9. So 10 minus 9 equals 1, and we can bring down again a 0, or we can just put the ellipsis, the three dots. So if you have noticed, even if we continually divide the number, we're gonna still get 1 as its remainder, and the process continues endlessly. So that's why we have this repeating or non-terminating decimals. Alright? Now, how can we express these types of decimals into fractions? We have here an example. Let's change 3.1212 ... to its fraction form. To do this, let's take a short review of the concept of place value. Now, if we have 12345.6789 as our number, the numbers will be given a particular value based on its place from the dot or from the point. The numbers 6789, this one, are placed after the dot or after the point. So we will call these numbers as tenths, hundreds, thousands, and 10,000s respectively, and so on. On the other hand, the numbers placed at the left side of the dot or of the point are named as ones. The 5 will be named as ones. The 4 tens, 3 hundreds, 2 thousands, and 1 10,000s respectively. Now, let's go back to our example. Let's change 3.1212 ... to its fraction form. Now, the first step is to let any letter be an equivalent to the repeating decimal. You can use any letter of the letter alphabet, but for this example, I use the letter J to represent the repeating decimal 3.1212. So let J equals 3.1212 ... and this is our first equation. Okay? Now, second, multiply this equation depending on the number of the repeated digits. If there is only one repeating digit, we will multiply it by 10. If there are 2 repeating digits, we will multiply it by 100. If there are 3 repeating digits, we will multiply it by 1000, and so on. But for this case, the number of repeating digits are only 2. The number 1 and 2 here. So since there are 2 repeating digits for this case, we will multiply it by 100. So 100 times j equals 100j. 3.1212 ... times 100 equals 312.1212 ... Since there are two zeros in 100, we will just move this dot or this point 2 times to the right. So we have here 1 and 2. So the 3.1212 dot times 100 equals 312.1212 dot. If you have noticed, we have moved the dot or the point 2 times already. And why is that we still have dot 1212 again, this one? So the explanation for this is that we have here the ellipsis, which indicates that the numbers 1 and 2 are repeating. So that's why we can still put 0.1212 or 121212 dot again and again. Alright? Now, 100j equals 312.1212 dot is now our second equation. Our first equation was this one, and is this one, and our second equation is this one. Okay. Now the next step is to subtract it by the first equation. So we will subtract the first equation to this one. So we have 100j equals 312.1212 dot minus the first equation, j equals 3.1212. So the answer is 100 minus j equals 99j. 312.1212 dot minus 3.1212 dot equals 309. So we will just cancel this dot here, because this 0.1212 dot occurs, or it is both present in the two numbers, in this number and in this number. So we will just cancel it down. And 312 minus 3 equals 309. So this is our new equation. 99j equals 309. Now after that, we will divide both sides by 99. So 99j divided by 99 and 309 divided by 99. Why? Because our goal here is to get the value of j. Okay? So we will get the value of j in its fractional form. If you have noticed, this 309 over 99 is already a fraction, but we still need to reduce it in its lowest term. And in order to do that, we need to know the greatest common factor, or GCF, of 309 and 99, which is 3. And when we talk about greatest common factor, that is the greatest number that can divide the number in the numerator and in the denominator, of course without a remainder. So for this case, our GCF is 3, the GCF of 309 and 99. Alright? So 309 divided by 3 equals 103, and 99 divided by 3 equals 33. And this 103 over 33 is our answer, or we can convert it into a mixed fraction, which is equal to 3 and 4 over 33. The first one is an improper fraction, while the second one is a mixed fraction. If you want me to make a video about fractions, just comment it below. Okay, so our answer here is 103 over 33. So therefore, 3.1212 dot equals 103 over 33, or 3 and 4 over 33. So this is, or 103 and 3 over 4, 3 and 4 over 33. So these are the fractional forms of the repeating decimal, this repeating decimal. Alright? So for you to better understand the concept, let's have another example. Let us change 4.345345 dot to its fraction form. So the first step, let a equals 4.345345 dot, which is our first equation. So for this case, I just use the letter a to represent or to equate 4.345345 and 345 dot. So that's it. Second, how many repeating digits are there in the repeating decimal 4.345345? So we have 3, 4, and 5. So we have 3 repeating digits. So we will multiply the first equation by 1000 because there are 3 repeating digits. So A times 1000 and 4.345 times 1000. So we have here A times 1000, 1000A equals, just copy the equal symbol, times 4.345 times 1000. So this process is what we call the distributive property. So we will distribute 1000 in this area and in this area too. So we have 1000A equals 4345.345 and this is now our second equation. And then let's subtract it by the first equation. So our first equation, we will subtract it from 1000A from this second equation. So we have here 1000A equals 4345.345 minus our first equation. So 1000A minus A equals 999A, and 4345.345 minus 4.345 equals 4341. Why? So we will just cancel this because these repeating decimals are present in the both numbers, in this number and in this one, so we will cancel it down. And then 4345 minus 4 equals 4341. And then we will, what's the next? The next step is to divide A by this number, by 999, and this 4341 will be divided by 999 too. So we have here. And then 4341 divided by 999. So we can find the greatest common factor for these numbers in order to reduce it in its lowest term. So for this case, the greatest common factor, or GCF, is still 3. So 4341 divided by 3 and 999 divided by 3, we have here 1447 over 333, because 4341 divided by 3 equals 1447 and 999 divided by 3 equals 333. So this is now our answer, and we can convert that into its mixed form, its mixed number. So 4 and 115 over 333. So the repeating digits, the repeating decimal, 4.345 equals 1447 over 333, or 4 and 115 over 333. So these are now the fraction forms of this repeating digit, or this repeating number, decimal. Okay, so I think you have already learned the concept, so it's your turn now. Change 5.67. So we have here the vinculum, which means that these digits are repeating. So change this number into its fraction form. If you know the answer, just comment your answer below.